Hello everyone, this is Gort on Stym's Redstone server with a tutorial for my Tic Tac Toe machine. A lot of people have been trying to build their own Tic Tac Toe machine and they've been asking for tips from me, and I figured the best way to do this would be to just talk about it. This machine is full featured except for AI. It has ports for artificial intelligence in the future, but right now it is just a two-player machine. The only thing it doesn't have is a tie game detector, but it does have everything else. Spam proofing, turn detecting, turn indication. It has move validation and win detect. So if we try to take someone's space, it will not allow us to do that. A lot of machines will overwrite, or they will skip the turn, or things like that. But this is smart enough to not toggle the pieces or stack the pieces, and it knows not to change the turn until it gets a valid move. So let's take it through the win sequence. Now once it goes through a win, you'll see it waits a few seconds. It flashes right away on win, and then wait a few seconds and it resets automatically. So let's do that again. Just one of them, and as you can see, this machine is actually very fast. If I hit the button. So now you'll see once it detects a win, it starts flashing that player's move indicator, and then it'll go through a reset. There are also two manual reset buttons on the bottom. If you press either one, it will reset it. The game always resets to player 1, but it can also be it can be reconfigured to have the winning player go first on the next game, or it be random. This one's just set to always red. So now on to how the machine works. This is the wiring, and it may look intimidating, but it really is pretty simple. I built this machine, not this exact one, but a very similar one that looked pretty much the same except for the display board, for my first rank up on the server. It took me maybe a month of figuring things out, maybe even less. I don't know. But all I know is it took me longer than I wanted, but shorter than most people. So I was onto something, I guess. So I guess we'll start with the buttons. These buttons are inverted right away, and they're split off into a 5x5 spacing, as you can see with this model here. There are no repeaters, no garbage in here at all, just straight up wiring and blocks, and then they are inverted again so I can show you what's going on. So let's hit the middle switch. As you can see, the middle is lit up. Pull the lever on the top left. That one lights up. Alright? You get the idea. So this is used in conjunction with a lock. Now this lock is set up like an AND gate. So see, this top right is off. Now it's on. So if we were to put a lock on here, like the system over there, it would be just an AND gate like this. So in order for that torch to turn on, both this and the red must be off. So let's say it's red player's turn. Let's pretend that this is red. You know what? Let's do it this way. Let's pretend it's blue. And actually, we won't even have to pretend. Maybe if I type the command correctly. Okay, so it's blue's turn, and the red is the red player's lock turn thing. So if it's blue's turn, this red wire would be off. If it's red's turn, the red wire would be on. So let's say it's blue's turn, so it's off. This thing is off. So now when we press a button, these would be buttons. So now when we press a button, it will allow us to send the input through. But if it was red's turn, that would be on. And it would not allow us to send the input through. Okay? So every input has one of those over here. You'll see this blue on the red. That's what this is. This whole bank of torches is the locked inputs. So this must be off, and one of the buttons must be off in order to send an input pulse through. Once the input pulse goes through, it will go to this section, which leads to the latches. But before it hits the latches, it will go through this brown section. This brown, these repeaters here, and the brown wool is for spam protect. This makes it so that once a button is pressed, it will send it through to the rest of the machine, but it'll also send a pulse up onto the brown, down this way to a pulse extender. And this pulse extender will lock out this blue section until the rest of the machine decides whether or not the move was valid. So a little bit about this pulse extender. It uses comparators. Don't be afraid of them. Comparators are your friend. I understand you may not know how to use them, but here's a quick little thing about them. Comparators on the back end, let's say, you know how redstone will only go, 15 blocks before it dies out. So a comparator will output what the input is. So as you see, that's not powered. So this is a signal strength of 1. That's a signal strength of 1 because it transmits what it receives if you're not using the side input. Let's just pretend the side input doesn't exist for right now. So what we're doing here is we are taking a 15 input. 15 is going to power this wire. Comparator is going to take it, output 15, and then it's going to die down to 14 on this one. So this comparator is going to output 14 into the block. And the block's going to make this 14. And this is going to take it and output 14 there, bring it down to 13 because it travels down the wire. And then it's just going to cycle over and over and over and just drop one signal strength gradually. You can see how it fades. Alright, so that's what I'm doing to extend the pulse. That gives the machine enough time to decide if the move is valid or not. It's important to use repeaters on your inputs and outputs of this. Otherwise you'll get some pulsing, and that's not fun. So we'll do it like this. You can kind of decide they'll act a little bit differently in different spots, but pretty much you can put the repeater in and out anywhere. It's not going to be that much different. So you can see how I use it in this. This is a one cell model of the Tic Tac Toe. That means that let's say this is like the top left space. This being the top left space for both players. So that's red, that's blue. It has the turn lamp. The purple is reset. I pretty much always use purple for reset on everything. So we can see on the back of the button it has the torch. Here's our AND gate for our input lockout. So if it's blue's turn, that would be on. It wouldn't let red change the state of this torch. So if red inputs, and it was red's turn, now let's just go to blue because it is blue's turn. So if blue presses the button, turns the torch off, that wire's off, that torch would turn on. That torch turning on would turn on this repeater, and it would send the signal both ways. So it would go down brown, and it would go down that way to the rest of the machine. First on brown. It's going to pulse this way into this repeater. This repeater is going to turn on this pulse extender. This pulse extender is going to feed back to its own lockout. So when blue presses a button, it's going to lock it out real fast. It's going to take only 1, 2, 3, 4, 5 ticks. 5 ticks to send a lockout signal to itself. That's half a second. That's pretty much that's as quick as it really can be, and that's going to be faster than anyone can get to another button. So it'll make it so you can press this button and you won't be able to press another button real fast to try to send 2 or even 3 moves down the line to cheat. And this will stop pulsing and allow the player to go again if it was an invalid move. So onto the spaces. This is an RS NOR latch. This in cyan here. These are basic memory cells. Here's an example right here in red. The button there will turn that on. The button here will turn that on. They just trade off. So what we're doing here is we're using one side for the user to input, and once it changes, you can't change it back. The user can never change it back. It has to wait till the reset happens, which is this button. So when the machine resets, that's when all of these reset. The player can only touch this side. So once it's on, it's on. It's done. You can never turn it off, and that's used to feed a lockout for the other side, which I'll explain. So this uses a different shape of RS NOR latch, but they function the same. This the player will input down this line as long as it meets the criteria to bypass this. It will come down this line, and it will turn off this line. So let's say we turned it on. There it goes. This torch will keep that on, and this torch will let that turn off. Alright? The only time that's going to reset is when you reset. That's this line here. So when these torches turn on to do a reset, which is this button here, and these will turn back on. Alright, so let's say red placed their move down, and that will let this latch turn on down there and turn off up here. Turning off up here will do 3 things. It goes in 3 main locations. Actually, yeah, three 3 locations total. So it's going to first go overhead. Alright, and you can see that up here. These lines, I call them crossovers for probably obvious reasons. These latches will turn off and go over the crossovers. Now it may be difficult to see what's going on here, but you can see there's the 3 red lines going that way, and then there's the blue, red, blue, red, blue, red, blue, red going that way too, and then there's 3 blue lines going that way and that way. Alright, we are taking from the red up this red crossover. Let's say the top middle piece was activated, so that means that this would be off. I'm just going to manually turn it off. Okay, so then that turns off this crossover. When this crossover turns off, that will turn on 2 torches that hang over the crossovers. 1 torch goes to the display, as you can see here. Top, middle, red. Red is the X or plus. Alright, now this crossover doesn't stop there. Crossover keeps going to this torch here. This torch hangs over the other player's matching space. So top middle of red comes up this crossover, drops down from this torch to the display, and keeps going to the space lockout of the other player. So now, if it's blue's turn, blue cannot try to take that space. I can hit that space all I want, and I can even manually try to take it. So here's the top row, middle piece. I'm going to hit that. You can see it turned on down here, and it turned off on the left side over there. I'll put this wire back, but it's just going to turn back on because this right here, this torch, is powering down. It's not coming from there. But not that torch. Did I reset it? Something reset it. Oh, it forced, when I broke that wire, it forced things to... I screwed myself over there. I shouldn't have broke that wire. Anyway, I was trying to make it obvious as to where things were coming and going, but breaking that wire actually broke the machine. So, anyway, I will... Dude. Oh, okay. Too many things broken. Alright, let's say blue took that space now. Blue on the top middle. So that allows this to turn off. This line being off will turn this torch on, meaning that the top middle for blue, it will be on, which is circle, or O. Then this crossover will keep going to this other one. Now this other torch is on. This torch being on will never allow this line to turn off. So I'll do it again. I'll break this latch here. Doesn't work. Cannot take that space no matter what. So now if that player tries to input the top middle, then it will just let that player go again until they take a space that's valid. Now on to the rest of it. See, it goes up the crossovers, but it keeps going also, and it is inverted. This inversion leads to the wind detect and move the turn flip-flop. This being inverted allows the correct inversion for an AND gate for the win. Each of these green spots is a decoder for a win. I'm not going to trace out everything, but I'll give you the basics. If let's say the bottom row is all activated, that means that these torches would be all three on. I seem to be missing a torch. Maybe? Yeah. So if all three of these I don't know how that's supposed to... Oh, no, I was not missing a torch. That was just a special case scenario. Anyway, so if all three of these torches, this torch, and this torch is on, that means that all of these lines on the bottom would be on. These three orange lines would be on. Those three orange lines being on means that this torch and this torch and this torch over there would all be off. All three of those being off will allow this whole green thing down here to turn off. If that is off, that will turn on. Right? There's one of these for every single 8 wins for each player. So there's 16 win scenarios. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 16 wins. So each player having 8 wins. All tied to this point here. Alright, they all feed down little buses. It's kind of a jumble of wiring, but you should be able to tell what's going on. I'll just in case simplify it out here. Okay, here is the let's say this is for the red player. Alright, no wire. Alright. Okay, so let's say none of these are on. So none of these pieces are activated. None of these spaces are taken by the red player. Now remember, these win decoders, each player has a win decoder. Alright, it's not a joined decoder. Each win is hard coded by the wiring. So let's say that was turned on by red, so that's X on the bottom row. Alright, we got 2 X's on the bottom row. Now we got one more left. That one open one that's still on, that still being on, keeps that line on, keeps that torch off. Now when all 3 are turned on up here, that means all torches here are turned off. All torches here turned off means that one is on. That one being on means happy win time. So that will then send a pulse up here, around this way, down that way, to a clock. Alright. Also, it will send a signal down that way. That green will shut off the input with this to the player lamps, so it will not tell whose turn it is anymore. So it will shut off that signal, and then it will clock it with this clock here. Right, so you can see that. You can see like player 1 just won. Okay. The other thing back here that should wrap up the wind detect. If it doesn't, hunt me down, let me know. This pink stuff back here, very important. Alright, so it goes down these orange lines for orange or the light blue. It goes down those lines through the wind decoder onto these pink things. These are monostable pulsers. Right? That means it will pulse one time when these lines go high. So if the top left space was taken, this would light up. It would send one pulse that way. I don't know if you saw it. Take another look. See how it just quickly pulsed there? Alright. Now, the reason it's at 1 tick is so that I can use it to power a flip-flop. Alright. Now, remember that no other repeaters can be on 2, 3, or 4 ticks. Every repeater in this chain has to be 1 tick, otherwise it will be buffered up to 2 ticks, and you won't have that 1 tick pulse. So you can see that in the simplified model down here. It's going to come up here. This is the flip-flop piston, right? That 1 tick will power this piston real quick, and it'll confuse it into pulling or dropping that redstone block into one of these positions. So if blue took his turn, oh, he can't, it's locked out. Let's reset. Blue takes his turn. That flip-flop is gonna flip or flop, whatever. Alright. Then we'll see it over here after I reset. Remember, I have to reset this every time because it's just a single cell. Yep, see that? Alright, so now it's blue's turn. That works over here with this. It's hard to see in there. It's that piston down there. Alright. Something else to get into is this display. It's a neat little design where the O's and the X's can be put on it. It's really compact. This it gets the X through this center line here. Just goes through that repeater into the lamp directly. The other ones they come up this way to this repeater and power this block with wire on it and this block with wire on it. Same thing with the other side. Doing that will power the corner blocks and the center blocks, which don't really matter. It's the important part is hitting those corner blocks. If you power the corners, then it will make that O shape. So a little bit more about the pink stuff. You can see them coming off each one. Each one needs its own pulsar. You cannot have you can't have one line attached to one pulsar, and it has to be a pulsar because that flip-flop will not work otherwise. So there needs to be in total 18 pulsars. I've seen where people try to do one pulsar and the machine just won't change turns, or it'll do it once, then it gets locked, and it just will not work. So put one of these pulsars on each space for each player, and you will have the perfect system. I think that just about wraps everything up. So if you have any questions, oh, no, one more thing, a couple more things maybe. On a win, I used another one of these comparator pulsers. I used it in reverse, so this is inverted so that this is always on. Alright, this is always on, that torch always off, and it leads to the reset. So on a win, it gets sent up to the display, but it also gets sent down here to this timer. So anytime a win gets fed over, oh, that goes up and then comes back down. Don't be confused by this. It does come back down here. So anytime that this turns on down here, or that end turns on, it will power this block. That will turn off, and it will stay off until the reset is done, because those lines will all stay activated until they're cleared. So this will turn off, and that will start draining. This is our timer to wait for a reset. Once this is fully drained, this will turn on, and that turning on will turn these off. Those turning off will allow these torches over all the latches to turn on. Alright, there's one for each space. Alright, that's how the reset works. There's one on each side. These are further back over here. Alright, so that's the automatic reset. There's also the manual reset. Manual reset buttons come in down here. They go over this way, and they do the same thing, but they don't have to go through this delay. Alright, so I think that pretty much sums it up. The only thing I really didn't go over was this goofy control wiring here. That's not all that important. Basically all you need to know is that depending on the position of this turn, different things need to light up. This player needs his light to go on, that one needs his light to go on whenever appropriate. The other thing is this yellow stuff. Yellow stuff you can ignore. It was put in there as an extra animation so that if this was on, then the whole board would flash when someone wins instead of just the player turn lamp. But it's just kind of laggy, so I leave it off. So that should do it. Have fun, and let me know if you have any questions.